Selamat malam, Profesor Heri Hermansyah. Saya Yusra Yuliana dengan NPM 230629493, mahasiswi PPI FTUI batch 11, kelas 1 akan membahas safety case study mengenai explosion at ExxonMobil Refinery in Torrance, CA, USA. Pertama-tama saya akan membahas mengenai identitas perusahaan bahwa ExxonMobil ini merupakan produsen bahan bakar dan petrokimia. Lokasi perusahaan di Torrance, CA, USA, dan overview perusahaan yaitu ExxonMobil Corporation adalah perusahaan minyak dan gas multinasional Amerika yang berkantor pusat di Irving, Texas. Perusahaan ini merupakan keturunan langsung terbesar dari John D. Rockefeller Standard Oil Company dan dibentuk pada tanggal 30 November 1999 melalui penggabungan Exxon, sebelumnya Standard Oil Company of New Jersey, dan Mobil, sebelumnya Standard Oil Company of New York. Kemudian refinery ini dibangun di area publik dengan 330.000 warga di sekitar refinery, kemudian 71 sekolah dan 8 rumah sakit. Kemudian di refinery ini ada yang namanya unit fluid catalytic cracking. Apa itu? Yaitu mengubah minyak kental bernilai rendah menjadi bensin bernilai lebih tinggi dengan memecah molekul besar menjadi molekul yang lebih kecil. Bisa dilihat di sini FCC layout-nya. Kemudian kronologinya 11 Februari 2015, expander mengalami masalah getaran yang parah. Kemudian 12 Februari 2015, bilah expander dibersihkan dalam upaya menghilangkan penumpukan katalis yang mungkin menyebabkan getaran. Kemudian 15 Februari 2015, expander mengalami masalah getaran yang parah lagi. Kemudian 16 Februari 2015, bilah expander dibersihkan lagi, namun tidak ada pengurangan dalam getaran. Kemudian 16 Februari 2015, getaran mencapai titik settle tinggi dan FCC shutdown serta berada di area safe park. Kemudian pada tanggal 18 Februari 2015, span katalis slide valve atau SCFV terkorosi dan katalis bocor lalu masuk ke generator. Kemudian dilakukan pemasangan blind oleh pekerja, namun tidak menghambat hidrokarbon bercampur dengan udara yang mengalir ke ESP, membentuk campuran mudah meledak yang membuat api dalam ESP di tanggal 18 Februari 2015 juga. Kemudian di rentang tanggal 11 sampai 16 Februari 2015 sesuai kronologi yang tadi saya bahas, expander mengalami getaran. Kemudian di rentang tanggal tersebut juga bilah expander dibersihkan sebanyak 2 kali namun tidak ada pengurangan getaran. Dan akhirnya FCC dalam keadaan shutdown dan berada di area safe park. Kemudian tanggal 18 Februari 2015, SCSV terkorosi dan katalis bocor masuk ke generator dan dilakukan pemasangan blind oleh pekerja namun tidak menghambat hidrokarbon bercampur dengan udara dan masuk ke ESP dan memicu peledakan. Berikut adalah video terjadinya ledakan di kilang ExxonMobil Torrance, CA.
The Torrance Refinery is a 750-acre facility located just outside of Los Angeles, California. At the time of the explosion, the refinery was owned by ExxonMobil. An important part of the refining process takes place in the facility's fluid catalytic cracker, or FCC unit. In the FCC unit, heavy hydrocarbons from crude oil are broken or cracked into smaller hydrocarbons, which can then be processed into gasoline and other fuel products. The heavy hydrocarbons are first fed into a reactor, where they mix with the catalyst. The heavy liquid hydrocarbons are converted into lighter hydrocarbon vapors as they travel up the reactor. At the top of the reactor, the lighter hydrocarbon vapors are separated from the catalyst. The hydrocarbon vapors then flow to the main distillation column. The catalyst falls down the side of the reactor where it moves through a slide valve to a piece of equipment called the regenerator. During the reaction, a layer of carbon called coke forms on the catalyst that must be removed. Inside the regenerator, air is added and the coke on the catalyst is burned off. The catalyst is then fed back to the reactor through a slide valve and the cycle is repeated. When the coke is burned off the catalyst, this creates products of combustion called flue gas. The flue gas flows out the regenerator and enters a system comprised of multiple pieces of equipment, which remove any remaining catalyst particles present. The regenerator and flue gas system comprise the air side of the FCC unit. The last piece of equipment in the flue gas system is called the electrostatic precipitator, or ESP. The ESP removes small catalyst particles using static electricity. While the ESP is energized, it creates sparks, which are sources of ignition. It is critical that the flammable hydrocarbons in the reactor do not flow into the air side of the FCC unit, as this could create an explosive atmosphere. To avoid this hazard, the two slide valves connecting the reactor and regenerator are used to maintain a catalyst barrier between the pieces of equipment. The sequence of events that eventually led to the explosion at the refinery began on Monday, February 16, 2015, when a piece of equipment in the air side of the FCC unit, called the expander, vibrated forcefully enough that the refinery's
Jadi di tanggal
control
16
system
Februari ini,
automatically
expandernya
transitioned the
bergetar
FCC
hebat
unit to
karena
a
ada
standby
penumpukan
mode known as
katalis.
Safe Park. During Safe Park mode, the flow of
Kemudian
hydrocarbons
FCC
into the
dalam keadaan
reactor is
shutdown
turned
dan
off.
berada di area safe
The
park.
flow of air into the regenerator is also stopped. The two slide valves connecting the reactor and regenerator are closed to ensure a catalyst barrier is maintained. Steam is then forced into the reactor to prevent hydrocarbons in the main distillation column from flowing back inside. The ESP remains energized during Safe Park. One slide valve, however, had eroded over 6 years of
Nah, di sini
operation,
SGSV
and even though it
terkorupsi
closed,
sehingga
it could
katalis
not maintain
bocor
a
dan
catalyst barrier
mengalir
in
ke
the
generator.
reactor. Within 7 minutes of the unit going into Safe Park, all of the catalyst in the reactor fell through the slide valve into the regenerator. A direct pathway was created for hydrocarbons to flow between the reactor and the regenerator. But the pressure of the steam flowing into the reactor as part of Safe Park mode was high enough to prevent hydrocarbons in the main column from flowing back inside. With the unit in Safe Park mode, operators attempted to restart the expander several
Kemudian
times,
operator
but were
memasang
unable to do
blind
so.
di daerah expander.
Refinery personnel met to identify a strategy to repair the expander and bring the FCC unit back online. Operations personnel predicted the expander could not restart because catalyst had likely accumulated inside. On Tuesday, February 17th, a meeting took place involving a group of refinery personnel. The group discussed a similar expander outage that occurred in 2012, for which the refinery had developed what is called a variance. A variance is a management-approved deviation from procedure. The group decided to use the 2012 variance, which allowed a departure from the typical requirements for isolating the expander. Part of that process involved installing a blind in one of the expander's outlet flanges. On the morning of Wednesday, February 18th, ExxonMobil Maintenance attempted to install that blind, but were unable to do so because steam was escaping through the open flange. Steam from the reactor had traveled through the leaking slide valve into the air side of the FCC unit. Using the variance as a guide, the flow of steam into the reactor was decreased in an attempt to reduce the amount escaping from the expander. But the variance did not evaluate whether this flow rate was sufficient to prevent hydrocarbons from flowing into the reactor from the main distillation column. And unknown to the operators, light hydrocarbons from a separate unit had flowed through a leaking heat exchanger into the main column, increasing pressure inside. With the flow of steam reduced and less pressure in the reactor, nothing could prevent the hydrocarbons from flowing back from the main distillation column. The hydrocarbons flowed into the reactor, where they escaped through the leaking slide valve into the air side of the FCC unit. At 8:07 a.m., a maintenance supervisor working in the FCC unit received an alarm on his personal hydrogen sulfide monitor, warning him that hydrocarbons were leaking nearby. By 8:40 a.m., multiple workers around the expander received the same alarm, and the FCC was evacuated. In an attempt to mitigate the problem, a supervisor ordered the flow of steam to the reactor to be increased, but it was too late. A flammable hydrocarbon mixture was flowing through the air side of the FCC unit and moving toward the ESP with its multiple ignition sources. There, the flammable hydrocarbon mixture violently exploded.
Ya, ini merupakan gambar di mana ESP itu meledak dan hancur seperti gambar ini. Kemudian dampak lingkungannya apa sih? Yang pertama munculnya asam fluorida atau asam HF yang merupakan bahan kimia beracun dan menimbulkan bahaya besar bagi penduduk dan lingkungan jika terjadi pelepasan. Kemudian asam HF juga menyebabkan kerusakan parah pada kulit, sistem pernafasan dan tulang setelah sistem pernafasan. Kemudian pelepasan asam HF dalam jumlah besar juga dapat berdampak pada ratusan ribu penduduk. Kemudian adanya munculnya debu katalis. Debu katalis dalam jumlah besar dilepaskan dari ESP. Kemudian debu katalis berjatuhan di dekat komunitas. Kemudian safeguard protection analysis dari ExxonMobil sendiri yaitu untuk setiap skenario dalam proses hazard analysis atau PHA yang mengidentifikasi bahaya besar yang potensial, maka pemilik perusahaan harus membuat laporan tertulis untuk menentukan keefektifan upaya penanganan individu, efektivitas gabungan dari seluruh upaya perlindungan yang ada untuk setiap skenario kegagalan dalam PHA, efektivitas perlindungan individual dan gabungan yang direkomendasikan dalam PHA, dan efektivitas upaya perlindungan tambahan atau alternatif secara individual dan gabungan yang mungkin diperlukan. Kemudian saya membuat fault tree analysis. Yang pertama risknya adalah pengapian ESP dan ada dua penyebab. Yang pertama aliran udara ke ESP dari CO boiler fans, kemudian kebocoran hidrokarbon. Nah, penjelasannya sendiri adalah yang pertama ledakan terjadi baik karena aliran udara dari kipas boiler CO maupun kebocoran hidrokarbon melalui STSV yang terkikis melalui sisi udara unit FCC. Kemudian yang kedua, adanya aliran udara yang disebabkan katup tidak ditutup dan tidak ada pemasangan blanch di atas kolom utama. Dan yang ketiga, di sisi lain kebocoran hidrokarbon terjadi karena STSV terkikis karena penggunaan yang lama dan karena operator mengurangi laju aliran uap. Sekian presentasi dan video safety case dari saya. Apabila ada kekurangan mohon dimaafkan. Terima kasih atas kerjasamanya. Sampai jumpa kembali.